get your book out, and if you'll turn to page 71, number 40, I'm going to read the problem. And number 40 says, a small fish is dropped by a pelican that is rising steadily at 0.50 meters per second. And the first part of the question is, after 2.5 seconds, what is the velocity of the fish? So basically, you got this pelican that, you know, is rising. See if I can get my pen to work here. Not yet. Let's hit this up here again. There, it's going to work. Maybe. So we got a pelican that is flying here. Here's his feet. And he's got that big beak, right? That's supposed to be his eyeball. So he is moving upward. That's directly upward, and his upward movement is 0.50. That's two significant figures, meters per second. Now, when the pelican drops the fish, so let's draw a fish here. When the pelican drops the fish, guess what? The fish is also moving up at that same velocity. So this is concerning the fish now. The initial velocity of the fish is going to be a positive 0.50 meters per second. All right, that's the initial velocity of the fish. They gave us time as 2.5 seconds. In other words, in 2.5 seconds, what is the final velocity of this fish? That's what we're looking for. Now, let me erase that and move it down one, because I forgot to write one other known in here that we know this is a falling object. Therefore, we know that acceleration is g, which equals negative 9.81 meters per second squared. All right? And then we're looking for final velocity question mark. Now, if you look at your four equations, you're going to know, and by the way, you get points for all this right here that we just, so be sure you show work on your test. But the equation we would use is VF equals VI plus AP, where A is equal to G. It's supposed to be an equal sign. So in other words, the acceleration is G, not negative 9.81. So all we're going to do is substitute in and say VF equals positive 0.50 meters per second plus a negative 9.81 meters per second squared times 2.5 seconds. Now, when all said and done, we have two significant figures in two of these numbers and three in another one. So we're going to have to divide, or we're going to have our answer in two significant figures. So if we go ahead and we're going to subtract 0.5 from both sides, right? And no, we're not. What am I doing? I don't have to subtract anything. I just have to add these together. I'm looking for VF. So it's going to be 0.5 minus parentheses, this is what you do in your calculator, 9.81 times 2.5. Or if you want to put a plus and then put a negative with your 9.81, it's the same thing. Then you get negative 24.025. So negative, so VF equals negative 24 meters per second. Now the negative just means that the fish is moving down. Okay? So I'll give you guys just a few seconds to write that down, and I'm going to erase it. And the second part, I'll go ahead and read it, is how far below the pelican is the fish after 2.5 seconds. So just so I have room, I'm going to erase all this right here. Maybe. All right. And you all can play it over if you need to be able to see and write down. But that's how you do that problem. And it wasn't too bad if you knew what you're looking for. That's the reason we're practicing here, so we know what to look for. Okay. So the second part is how far below the pelican is the fish after 2.5 seconds, right? And we still have some knowns here. We know VI, of course, I shouldn't erase that part, is positive 0.50 meters per second. We know that the acceleration is equal to g, which is equal to negative 9.81 meters per second squared. And we know time is 2.5 seconds. And we also know VF now. We just calculated it, but I don't think we'll need it because what we're looking for here is delta y. Y meaning vertical distance as opposed to delta x, which is horizontal. So we're looking for that. And if you look at your 4 equations, you'll notice that there's an equation. I'm getting points for all this, remember, is delta y equals initial velocity times t plus 1/2 at squared, but we're going to say 1/2 gt squared because the acceleration is g. I just need to substitute all my numbers in, and I got delta y equals, actually, this is going to be kind of a longer equation, so let me move it over here to the edge. Delta y equals positive 0.50 meters per second times 2.5 seconds minus, okay, let's skip a step here. If you will, or if you'll just put, say, in your calculator, say 0.5 times 9.81, half of 9.81 is 4.905. 4.905 times 2.5 seconds squared. And of course, the units right here is meters per second squared still. All right, so let's multiply all this out. So 0.5 times 2.5 is 1.25. So I get 1.25 meters there minus 4.905 times 2.5 squared is 30.7 basically. So we'll write all that out. 30.7, and this is also meters. Don't forget to square your 2.5. That's a common mistake. So if I say 1.25 minus 30.7, I get 29.406, and that is part of my answer. Okay, I'm back. Anyway, our answer here is, I had to help a student that just came in. Our answer here, let me get my pen back on, maybe. Come on, pen. There we go. All right, is 29. I believe we get 29.4 or something like that. Now, if you look in your book, that's not the answer. And here's what we've forgotten. This pelican, because that's correct as far as this part, but this pelican is moving up at a constant rate of 0.5. So we have to add to that. We have to add to that the velocity of the pelican times the time that the pelican moved, which is still 2.5. So we have to add to that 0.50 meters per second times 2.5 seconds. And when we do that, we get 1.25 or something like that. And so, pointer here again, so I'm going to make this page a little bit longer. And so if we do that, we get, need to be sure, 0.5 times 2.5 is 1.25, yeah. So you get 29.4 meters plus 1.25 meters, and when you round that off, this isn't the answer you get when you add those together. When you round it off, though, it becomes 31 meters, which is the answer in your book. Very easy. Now, what if you'd done this and got 29.4? I'd have only probably counted off 1 point because you did everything right. You just forgot that the pelican was moving up also. So the pelican also increased its distance as the fish increased its distance falling. So I hope that helps. And come by and see me if you need anything.